Good morning, my dear little children. Thanks for joining me in this tutorial. Yesterday we will look at limit integration by substitution. I'll give you 4 questions. Today we come to look at those 4 questions. We come to look at those 4 questions and see whether what we did were on the right path. Let's look at question 1. Question 1, we're asked to integrate x into bracket x squared minus 3 all squared. By substitution, we are going to let u equal to what is in the bracket, which is x squared minus 3. Then we can differentiate our u, which is du dx is equal to 2x. Then we'll make dx the subject. Now dx is equal to du over 2x. Then we substitute our u and dx. Now it becomes the integration of x u square du over 2x. By algebraic expression, this will cancel this. The x will cancel the x. Then we are left with 1 over 2 u square du. Then we integrate with respect to u, and that is increasing the power by 1 to get 3, and divide the results by 3. Then we add the arbitral constant of integration. Simplifying this portion further, I'm going to get 1 over 6. Then I introduce the value of the u, x squared minus 3, cube to the power 3. That's our arbitral constant of integration. So this is expected answer for question 1. You can pause the video and have a better look at. We're going to question number 3. Question number 2. Question number 2. We were asked to integrate over x 4x plus 5 or cube. Similarly, we'll let u be equal to 4x plus 5. Then our du dx will be equal to 4. Making dx a subject, dx will be equal to du over 4. Then we substitute both u and the u and the x, sorry. So that becomes the integration of 1 over u cube du over 4. This can be written as the integration of 1/4 u cube minus 3, sorry, by applying the lots of indices. I'll increase the power by 1. Increasing the power by 1, I get minus 2. Then I divide by the results, minus 2. So this becomes minus 1 over 8. And I introduce the value of the u, 4x plus 5 raised to the power minus 2. That is question number 2. You can pause the video to have a better look at it. We are going to question number 3. Question number 3. We are asked to integrate this function. As usual, our u will be equal to 2x squared plus 1. And our variant function du dx equal to 4x. And making dx the subject, we're going to have du over 4x. Good. Then we substitute the x and the u. So we'll have the x and then the u. So we have 3x all over u, square root of that. Then u over 4x. Then we apply our knowledge of algebra to cancel these two. And proceed. We proceed. So this become the integration of 3 u raised to the power minus half dots 1/4 du, or better still, 3 over 4 u raised to the power minus half du. Then we integrate this function. We increase the power by 1, sorry, and it becomes half, positive half. Increase the power by, and we get positive half, all over positive half. Then we add arbitrary constant of integration, and 3 over 4. Reciprocate this and multiply u power half. This becomes the 2 will cancel the 4 2 times. So we are left with 3 out of 4. Sorry, 3 out of 2. The value of the u is 2x squared plus 1. Then all raised to the power half as the arbitral constant of integration. Always remember add the arbitral constant of integration. So that's number 3. We go to the last question. The last question. Remember, I made a correction on the last question. We were asked to integrate x minus 1 over x plus 1 all raised to the power 3. As usual, our u will be equal to x plus 1 or dy dx, du dx, sorry, equal to 1, making the other subjects means dx is equal to du. We are going to substitute these two to s minus 1 over u cube du. We have to find a way of removing this x before we can differentiate with regards to the u. In order to do that, we should remember that from the beginning of the calculation, we said the expression u is equal to x plus 1. So we can make as a subject from that equation. So from that equation, I can say x is equal to u minus 1. Remember, I just sent the 1 to the other side. Then we'll substitute this here. We substitute that here. So we'll now come and have the integration of u minus 1 minus 1. Remember, there's already a minus 1 here already. It's a minus 1. So continuing over u cube du. Simplifying further, we get u minus 2 over u cube du. Then we split the fraction, u over u cube minus 2 over u cube du. Then we simplify further, become 1 over u square minus 2 over u cube du. This can become the integration of u raised to the power negative 2 minus 2 u raised to the power negative 3 du. Then we integrate term by term. Increase the power here, we'll get positive 1. Sorry, negative 1. Negative 1. Then we divide by the negative 1. Increase the power here, we'll get negative 2. Then we divide by the negative 2. Then add arbitral constant of integration. This will become minus u negative 1 plus u negative 2 plus arbitrary constant. So we can have, finally we have x plus 1 negative raised to the power negative 1 plus x plus 1 raised to the power negative 2 plus c. You can use indices to redress this. This becomes minus 1 over x plus 1 plus 1 over s plus 1 squared, s plus 1 squared, plus the arbitrary constant of integration. Okay, so that is that.